Okay, so if the value is greater than our diagonal A is greater than B, then we're going to get a formula. Oh, we've got to display it in LBL question 1 underscore 2, question 1 underscore 2 dot caption equals float to string F. Here we have to display it to 2 decimal places, FF fixed, comma 8, comma 1 decimal place actually. So that was that. But that's that, begin and end. Now what's the second option? Are we having an else part here? If the value of diagonal 1 is not greater than the value of diagonal 2, display a message, and that displays that. So I'm going to put an else here. Else, begin and end. Remember, no semicolon before else. Suitable message restates that the value of diagonal 1 must be greater than diagonal 2. Okay. Show a message. Basically saying that diagonal 1 must be greater than, I don't know how we're going to say that. The value of diagonal 1 must be greater than the value of diagonal 2. They're not actually, it is there, diagonal 1 and diagonal 2. Okay, the words diagonal 1, the value of diagonal 1 must be greater than diagonal 2. End of story. So that's that. What else do they want us to do if it's not? That's it. And that's the end of that program. 8 marks. Right. Now we have a binary number. Converting an integer number into a binary number is done by repetitive division by 2. In fact, we had this in my grade 11s this year to figure this one out. But they give you the algorithm, so you don't have to worry too much. Until the final answer of the division is equal to 0. So we know how to get our binary number from an integer. You divide by 2, what's the remainder? 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 And then you read the numbers from the bottom up. Join them from the bottom up. How do we translate that into an actual program? So we're going to figure that that's what they want us to do. Okay? So retrieve the integer number that was entered by the user. This is a very important question here. I'm glad we figured this one out. EDT question 1 underscore 3 is a number using the variable I number. Okay, fine. Let's go to 1.3. There's a variable I number. We've got to go and get the value from that edit box, EDT question 1.3. We might have to check it. String to int, because our number is an integer. If they ask us to check whether it is 1.3.text, if they ask us to check whether it's an integer or not, they will. If they want us to do, they'll ask us. If they don't, you don't have to. Now take note, they're not telling us to check that it is an integer. Then you don't have to use val here because they never asked you to, okay? So you won't be allocated masks. So you only do what is required. So initialize a string variable called sBinary. I'm just following the instructions here. I'm initializing it to an empty string. Convert the integer number to binary using the following algorithm. So they give us the algorithm. Repeat until the number value is equal to 0. Determine the remainder of the number value divided by 2 using our remainder. So let's go and do a repeat until the number value is equal to 0. Well, think about this. If we had to look at our algorithm, the thing here, the number is 19. Then it becomes 1. 1 divided by 2 equals 0. But does it really? I'm actually going to do it in a different manner. I actually prefer to do it in a different manner to this, but let's have a look here. What they want us to use this algorithm. Fine. Determine the remainder of the number divided by 2 using remainder. Okay, our remainder, the number value divided by 2. So we're going to say Ri remainder colon equals I number mod 2, because we know that mod will give us our remainder. Then join to the left of the string variable. So it's either going to be a 0 or a 1. So we're going to say S binary colon equals, we're going to join to the left, so it's going to be into string R remainder, join that to S binary. That's how you're going to join it to the left, not to the right of the string. Next thing, divide the number value by 2 and save the answer in the number variable. So we have to divide by 2 because we want the div part, okay? 19 divided by 2, well actually 19 div 2 is 9. The remainder is 1. So the div part we are going to now use as our number. So we say I number colon equals I number div 2. Oh wait, that's supposed to be inside the repeat loop, eh? Oh yeah, sorry. Right, and save the answer to the number variable. So repeat until the number value is equal to 0. Well, until our number colon equals 0. Will it really be 0 at any time? What's 1 divided by 2? It's 0, eh? So yes, it will eventually get to 0. There it is. And then use the label to display the content of the string variable. So they actually gave you the algorithm. This is quite easy. I mean, the grade 11s were tested there to do this without the algorithm. So use the label question 1 underscore 3 to display the content. And we'll do that in question, is it LBL question 1 underscore 3? LBL question 1 underscore 3. LBL question 1 underscore 3 dot. Now here's the tricky part. Displaying this, you have to use the original caption in the label. Okay, very important. Oops, it's out of the procedure. You have to use the caption again. You have to join your answer to the end of the actual caption that exists there. S binary. So there it is. So we put that in to S binary. I mean, we put it at the end of our caption and we're good to go. So I suppose we could run it and see if it works. What number are we going to put in? Which one must we check it with? 19, eh? Oh yeah, it was 19. Binary number 10011. Let's see if that's correct. Yep, perfectly correct. Now we're going to move on to the next question, 1.4. Okay, a word game needs to be developed where each character in a word carries a specific number of points. Each character has points, so the vowels are 3, anything not a vowel is 2, any other character which is not alphabet is 1 point. What if the characters are numbers? Anyway, player must enter a single word. When the button is clicked, the program must calculate and display the total value of the word in terms of points. If more than one word is entered, the player is disqualified. Right, so if there's a space, well, retrieve the word that was entered and convert text to uppercase. Find test for presence of a space, which indicates that more than one word is entered. So if the space, we're going to display a message. And this is quite easy. They're giving us the algorithm. If a space is not, calculate the total value based on the number of points. Display it in the rich edit. Guys, this is easy. I'm surprised. Anyway, here we go. Right, if EDT question 1.4 dot text. Well, we have to find the pos of the space in it, not so. But if pos of the space in EDT4.text equals 0, that's how you can find the pos of anything and anything else. That's just one space, then begin and end, else begin and end. Get your structure in, and then you can move on with the rest. Test for presence space has more than one. If it's identified, display a message, indicate the player has been disqualified, clear the edit box and set the focus on the edit box. We'll just show a message. They're not telling us to close the program or anything or exit the procedure. Disqualified EDT dot clear. Easy marks here. Dot set focus. All right, next one. If a space is not identified, calculate, that's the else part, okay? If the space was identified, then we're going to do that. Else, we're going to do this lot. So, calculate the total of the word based on the number of points. So that's going to be easy. We're going to go through each character, but we have to first convert it to uppercase. And we have to have our line, S word. We've got to have our variable S word. I'm going to say S word colon equals EDT question 1 underscore 4 dot text. I'm going to uppercase it while I'm about it, uppercase, because it makes it easier to find all those things. And then we're going to say for K equals 1 to the length of S word. We will go and do our, I'm going to use case, S word, character K of, because I find it much easier to handle. And I'm going to put in these letters. Actually, no, case is not going to work here. Because we can't go and put all the composite letters in there, so we're going to have to use an if statement rather. I'm going to say if S word character K in, well, I say, in our set, A-E-I-O-U, you know those are the set of vowels, eh? Then we're going to increment something, counter. Now, how are we going to do it? We can use the else if S word character K in the set of A to, let's figure that one out, eh? Because if we used case here, it would also work actually in this respect. We'll increment another one, but I'm going to work it out with this one rather. We're incrementing the same counter. Remember, we're going to add 1 or 2, whatever, if the character is else. We will increment, because if it's anything else, we're going to increment by another number. So we have this counter that we're incrementing each time, and these are basically nested for loops. If statements. Sorry, nested if statements. Not for loops. Let's see. There's one for loop here, and k is going from 1 to each character. And it was a bit of a trick question here, because you might think, oh, it's easy, but then you have to get all the vowels, 3 points, anything that's not a vowel is 2 points, and any other character is 1 point. So using this, if it's in ARU, because that's the first test it's going to do, the else part will not happen. So if the character is in AEROU, this else part will not happen. Nothing in the else will happen. If it's not in the set of A or R, then in the else part, they're going to check for A to Z, okay, which will be the consonants. But we can't go and list all the consonants in a square brackets here. That will not be good. That will be hard coding. You'd lose marks. So we'll increment there, else. That is going to be for everything else. Just remember the else part will not happen if that first section, the first if statement is true. If the first if statement is false, then this else part they'll check. But if the second if statement is false, then this third, this other, what happens here, else will happen. So we have 3, 2, 1. We have to go and get our counter. Our count. Our score or something. Set our score to 0 before we do anything. Must be 0. And then after that we can just increment our score with 3, 3 over here. Increment our score with 2 over here, and just increment our score over there, which means it's going to be incremented with 1. Did you know that you could use 2 parameters in the increment method? Increment procedure. And then at the end of it, we have to display the total value of the word in the provided rich edit. It was 3, 2, 1. Hey? I'm going to test my program with some words here, and let's see if it actually does work. We were putting it into this one here, RED question 1 underscore 4. We have to go and say total number of points. Make sure that we use we're inside the right thing. RED question 1 underscore 4 dot lines dot add. Even though it looks like a little edit box, it's not. It's a rich edit, so you still have to say dot lines dot add. And I'm going to put in here S word. Sorry. And join that to points equal there we go. Run the program. Let's see, we wanted the word win, eh? Win. It's supposed to be 7 points. Disqualified. Oh, did I have a space there? Disqualified. Now, obviously my algorithm is not correct here, because I had this. If part of the space is naught, then we're going to show a message, else begin and end. Okay, just going to put this over here. Pause of the space. Yeah. Oh, not equal to naught. Thank you, sweetheart. I just remembered. How silly of me. Okay, win. Pass. Yeah, 7, 7, and it works, and it works. Right, so I'm not going to test the other one. Oh, might as well. Non-subscriber. We must test all of them. Non-subscriber. Sub. 31. Okay, so that's it.